Welcome back to the exam walkthrough. We're going to be going through question 15, 2025 Jan, Unit 4. And I want you to pause the video, try out the question. This is the full question. And for the examiner report and the mark scheme, you can go to the end of the video. So a washing machine uses a rotating drum to wash clothes. The photograph shows the drum inside a washing machine. The clothes are put in the drum. The drum is a hollow metal cylinder with a series of holes through its surface. At the end of the washing machine, the drum rotates at a high speed. Part A, the drum of the washing machine rotates at 1,400 revolutions per minute, and you have to show that the angular velocity is about 150 rad per second. So if 1,400 revolutions take 60 seconds, then we can say for one revolution the time will be x, cross multiply, and we can solve it. And this x basically will be the time period, the time taken to go around a full circle and a full circle path. So that's going to be 3/70 seconds. And then what we can do is we can plug it in the equation. Omega is equals to 2 pi by t. So we're going to get the answer as 146.6 rad per second, which is approximately 150 rad per second. In the next part, it says the diameter of the drum is 45 centimeter, and you have to calculate the centripetal acceleration from a point on the circumference of the drum. So the radius is going to be 45/2 times 10 to the 12 minus 2 meters, and we already have the value of omega, so we can plug it in the equation. Centripetal acceleration is equal to radius times omega squared. So when you plug in the values, we're going to get the answer as 4,862 meter per second square. So part B says, as the drum rotates at a high speed, clothes move in a vertical circle resting against the side of the drum. The dot in the diagrams represent an item of clothing as it rotates with the drum. Part I says, add labeled arrows to each diagram to show the forces acting on the item of clothing. So here we have two forces. The first force is going to be the weight, and the second is going to be the reaction force from the drum on the clothing. And we can see that the reaction force is going to act upwards and the weight will act downwards. And in the second diagram, we have the reaction force acting down and the weight is also acting down. Now, do not write the resultant force, which is the centripetal force here, because that would be incorrect. Okay, you can't just write the centripetal force. You have to write the specific forces that are acting on the clothing, such as, in this case, the reaction and the weight. So in part II, they say the drum rotates at constant speed. Explain how the forces on the item of clothing vary between the bottom and top of the drum. Now the first thing you can write is that the weight will remain the same. The weight remains constant. Okay. So the weight will not change, but what will change is the reaction force. So what we can do is we can write two equations. We can write mv square over r, which is centripetal force, is equals to, so we're talking about this first diagram here, is equals to the reaction force minus the weight. We can see that the reaction force is in the direction of the centripetal force. So I'm going to say this is positive and this is negative. So what I've done then is I'm now written that the mv square over r is equals to the reaction minus the weight, and then I've made r, which is the reaction force, the subject, and that gives me the first equation, and this is the equation at the bottom. At the bottom. Now, at the top, what's going to happen, which is the second diagram, we can see that the reaction and weight both are in the direction of the centripetal force. So, we're going to say down is going to be positive and up will be negative. And then for the second diagram, which is at the top, we can say mv square over r is equals to reaction plus weight. And then we can make reaction the subject again, So mv square over r minus mg is equals to the reaction. Okay, now we can see here that when it's at the bottom, we have the centripetal force plus the mg. Here we have centripetal force minus mg. So here at the bottom, the reaction force will be maximum, and at the top it will be minimum. Okay, I hope that's clear. So the reaction force will be maximum at bottom and minimum at the top. Okay, that's going to get your 3 marks. So the last part of the question says, water leaves the drum through the holes as the drum rotates. Describe the path of the water as it leaves the holes. So when water will leave the circular path, it will leave in a straight line tangent to the circle. So the water moves in a straight line path, and that will be tangent to the surface of the drum. That's going to get you your 1 mark. Okay, so that's the end of this exam walkthrough. I hope everything was clear. Now I'll show you the mark scheme and the examiner report. And that's all for